And now we are live. Yeah. So MetaMask is like it's like a tool that you can use to send, and I don't know whether receive is the right word, but it can be used to help you sending money across networks. So they have some fake networks that. So don't click that. Don't click that first. Maybe you can unshare your screen because.
Okay. Yes.
Yeah.
Okay.
They say it's secret. So when you
secret backup phrases makes it easy to backup on I can never disclose. Anyone with this phrase can take your Ether forever.
Yeah, maybe you can
write this phrase on a piece of paper. Write it on little pieces of paper.
Yeah, you can take a screenshot, you know. You can take a screenshot.
Memorize this phrase.
Yeah, you can take.
Okay, I can stop my screen sharing.
Yeah.
Sorry. No. Yes, I stop it. No. Screen share.
Yes, and then and then you can take a screenshot of the words. So that in the next step you will be asked to arrange them as they were, as you create your account.
Okay. And it's a phrase. Okay. It's supposed to be easier to remember.
Yeah, but I think they just make it difficult, and they don't send it to your account. So when you lose those words and you have money in your account, there's no way. There's no way back.
No way to get them back?
No, if you lose the words, I think that's it.
Okay. And you use your account? Yes.
Yes. Yeah, there's an account that I have, and actually it has some little money, some little Ether. So let me see. Yeah, the value has just dropped. Last week it was a little higher. So once you've created your account, I think you can just share.
Next. You have got to confirm your backup phrase. Okay. So here we are.
Yeah, so you have your
and yes, you've got some kind of
that's sort of your account. And I think it's so unique that I think how they've made it. So if you look at the top left, top right, at the top right, that drop down, it leads you to some fake and real network. So I think the network that's selected now is the real Ethereum network, I don't know what it's
We
saying.
are at.
Yeah, and then there's that one that's down there is called Rinkby. Yeah, that's a test network. And there's one that's called Rinkby. Yeah, so this Rinkby one is I think you can send me your account number, and then I try sending you some money from my Rinkby. Let me see.
I send it by chat.
Yes, you can send by chat. So Rinkby. Oh yeah, so I only have one Ether. So I can send it to this. This is my. I can send 0.01. I don't know whether you'll accept. So this is the address, no conversion, insufficient amount. Yeah, so that's insufficient amount. Yeah, there was a link. There was a link that was shared a while back. Was it in Premium Extra? New. So the link was shared by New. So no, not there. There's a link that, let me just try finding it. Search New. Why is it kicking me out of Premium Extra when I search? So from New in Premium Extra. I think he did not. Maybe he just shared it in the chat. So there's a network where you could go and maybe send free Ether just to play with to your account. So that's just to learn how you send and receive Ether. But I think it's just easy. What you do, you come to MetaMask here and pick the network that you want, and then you click that send.
Yes.
Then you do an amount. Maybe if your account now has, I think it has 0. Yeah, so you have insufficient amount. So yeah, like the way you created your account, it has 0. It has 0 Ether. If you look at the
how do you
from
credit your account?
Yeah, so I think this is yeah, so we have a blocker there. I will ask Nicholas for that link so that we can play with sending Ether from and back next time. Yeah, but I think this is the tool that you use to manage your accounts. You can have many accounts from different networks as you have seen. You have the ring B test, you have the main network, you have whatever networks that you have. And then back to the course again. After he talks about the Ethereum accounts and receiving Ether, he comes and explains what a transaction is, whatever we were just trying to do, how you can make a transaction, what it means. And he goes and looks over the Bitcoin, the blockchains. He explains the concept of blockchain. And he just says that it's a chain of blocks. He gives a very good example in this. I think this even is from someone else. I don't know if we can listen to that, but it's just it just explains what exactly blockchain is and what block time is, and then he starts explaining what smart contracts are. And then at the part where I was writing my first contract using Solidity. So there's this Solidity. No, the link is called link. Yeah, I had a chat with so he was saying, yeah, Federico wanted us to start with episode 37, but then I went a little behind. So there's this channel called Ethereum. There's this channel Ethereum that's, yeah, you joined it. Okay, nice. So here Federico was saying how I was looking at Remix. Yes, it's called Remix. Remix.ethereum.org. So here in Remix, he just okay, what I was doing last time is to write this contract. So yeah, he in those videos he just explained the syntax, where this is here you select the version of the Solidity that you want to use. So the language that we use to write the Ethereum contracts is called Solidity. So currently you choose the version of the Solidity that you want to write this contract for, and then after you create a contract. A contract is like a class in C++ or Java or Python or Rails. So it's contract inbox, so it's like a class inbox. And then this contract has a constructor which has the same name as the class, but now you have to pass the initial message here. And so this is like a parameterized constructor, and you set your message to the initial message, and you declare your constructor as public. So this is where I was stuck last time. I don't know whether I can, yeah, this is exactly where I was stuck like last time, because I was getting these errors. So it's saying syntax error. Source file requires different compiler version. Current compiler is that, not that.
Checking transaction detail.
Yeah. So wow. So oh yeah, version is 0.5.1. Oh, so this is what Federico meant when he said. So functions are not allowed to have the same name as contract. If you intend this to be a constructor, use the constructor keyword. Yeah, but if I look at this
You've got
video,
a function inbox in inbox blah blah blah. It's no.
yeah. So let me just see what he did here. So this is what he created. He said pragma solidity 0.4.17. So this is where there was a problem. So this is the 0.17. Then I think it's difficult to do it this way. Yeah. So maybe I'll just cross that so that it doesn't confuse me. So I can pull this here. So I just have it next to this. So he created a contract inbox. Then he created a string public message. Yeah.
Yes.
And then after that, he did function inbox, string initial message, and that's what I added here. Function inbox, string initial message, and this constructor. So I also added these extra functions. But if you see how they declare their functions, it's different from any other language that we have, where we have this is the function keyword, and then after that we have the function name, and then we have the parameter, and then we have the this states whether the function is public or private, and then we have the returns. Yeah, so like for example, this one is a different type of function. So this is a function, get message, and it's a public view, and it returns string. So there's a place he explained the meaning of those words. Yeah. There he explains what public is. So public, anyone can call this function. Private, only this contract can call this function. View, this function returns data and does not modify the contract's data. So for example, if I come here, this one, it returns data, but does not modify the data. For example, this one, it just does a return. So it cannot do an assignment on message like message equals new message like this one does. So it just returns data. And then it says constant function returns data, does not modify contracts data. So he said view and constant, they mean the same thing. And then pure function will not modify or even read the contracts data. And payable, when someone calls this function, they must send ether along. He said in this tutorial, I think at some point he says that the pure keyword is very rarely used. So even in all of this course, we will rarely see him use the pure keyword. Yeah. So after this, that's when we had a chat with Federico. And so here he talks about deploying contracts and behind the scenes deployment, then more on running functions, then Wave versus Ether, gas and transactions. Yeah, so the gas, I think I've come to understand that the gas is the charge that they put on the Ether when someone is making a transaction. For example, if you want to send me some Ether, there's some money you pay so that you facilitate the transaction. Yeah, so that's what the gas is. And then mnemonic phrases. and getting more ether. So I don't know about this. So maybe that's not more concerned with the code. So here he does contract deployment, boilerplate requirements, then compile script. So in this section 2, what it does, I think Federico created a repository. I think Federico also experienced these strange things that I have. For example, it's telling me syntax error, yet I should not be having a syntax error. So he went ahead and created Agile Ventures. So I think he shared the link in this channel. Maybe he pinned it. No, he did not. Maybe he pinned it in Premium Extra inbox. They call it inbox. Yes, so he created this inbox and created the directory for contracts, then created inbox.so and created this and this, and maybe I should fork this. Yeah, I can send you the link to that. Yeah, I don't know. What's your interest with Ethereum, or do you just want to maybe learn, or are you interested in creating web applications with Ethereum? Yeah, because this course goes as far as
smart contracts deployment.
Yeah, so yeah, they're very long. So here, just smart contracts with Solidity. So I think here we'll just learn stuff about smart contracts with Solidity. And then we have advanced smart contracts, where he goes into the advanced things. Then he goes building interactive smart front ends, and then real projects with Ethereum. So I think here he solves solving real problem, creating contract design, a quick test, creating struct instances, all that. Wrong voting system, yeah. And then Ethereum project infrastructure, project setup, etc, etc. Then it goes to advanced multi-page front ends, which is also long. So yeah, and then he does a basic React app with with Ethereum as well. So I think he does a Vue flavored version, and yeah, it's a very long course, but I think it's huge. It's once we have done it to completion, it's going to be something. Yeah.
Interesting.
So
projects. Did you buy the course, or how did you?
Yes, I bought the course, and there's a token that Federico sent me, so that it went for me at $10. I may look it up and send to you, so that you can. Yeah, it's a token that it's given to premium members at Agile Ventures, so they can buy all courses on Udemy at $10.
Okay, I didn't know that. Okay, I'll ask Federico for a token. Or no?
Yeah, maybe I can even look it up, and I think it's in my chat with Federico. Yeah, maybe I'll look it up when we are not on the call and send to you.
Yes.
Yeah.
Okay.
Yeah, so I'll send it to you so that so I bought it at $10. So I think it also depends with the region, the location where you are. So some guys could get it at 11, 12. Yeah.
Okay.
Yeah. So
how much time do you have to complete the course? Is it a limited? Do you have a?
Yeah, once you buy it, you just have it.
And then you can go through it at your own pace, or you've got to complete it in a limited time.
No, you can go through it at your own pace. Like right now, I'm just going through it at my own pace. So
Okay.
I'm normally using just this 1 hour on Fridays. Yeah, it's roughly 1 hour on Fridays to get set up. Yeah. So maybe I'll go to my terminal and clone the repository that I've.
Where are you in the course?
I just started watching the course like.
Okay, you're just starting, and you plan to work on a chapter every week each. Yes.
Yes. I plan to work on at least something every week.
Okay.
Yeah.
So the mob is interesting if, for instance, I try to follow your pace on something like that. No.
Yes.
Yes. Okay.
Yeah. So that every time. Yeah. So that every time we have the Ethereum mob, maybe we have watched a few videos and we can discuss whatever was on those videos.
Okay.
Yeah, that will be interesting. Yeah.
Okay.
So here we have. I'll go CD to work.
And you do you? I think there's something about React. Yes. Do you? I have never programmed. I've never written code with React. Do you master React?
So I'm also just learning React as well. So there's also another course by the same guy.
Okay.
That course is actually free for premium members for Agile Ventures. I think when you talk to Federico, he can give the course to you. So if I just go to Udemy here, and yeah, this course, I can just show you the course.
Is it a requirement of the course about Ethereum? No.
No, but yeah, right now it's going at $32. But yeah, it's free for premium members at Agile Ventures. So this is it. I'm just watching it. I'm at like 50% of the course, and at the same time, I'm watching I'm doing the Ethereum Solidity one, where I'm at maybe 10%. Yeah, so Federico can give you access to this one.
Okay, so I have to. I must send a message on Slack to Federico. Okay.
Yes, and this one I think we are many guys who are doing it currently because we normally have the weekend collaborations where we go through this course on Saturdays and Sundays. So yeah.
It's interesting, the course about React.
Yes, it's interesting. Yes, it's interesting. Yeah,
and it's easy to
Yeah, you're saying?
Okay, it's a good course about React.
Yeah, okay. Yes, it's a very good course. Even it has very high ratings. You can see. Yeah.
Okay.
Yeah. So it's a very good course. So I'm also just watching it at my own pace. So I think yeah, that's the good thing with them, because you don't have time that's constraining you. Yeah. Yeah. So git clone. Yeah. So cd into inbox and ls. So you can do yarn install. Then I can do code this, maybe to see. So I don't know how to run it. Conspart. I don't know how to run it. And I don't know what it does. So maybe contracts box.so. Yeah, this is just inbox, and then they have this compile.js. So I don't know whether I should just run so maybe I should install Solidity. Solidity app locally. So running locally. Let me see. So node npm -v go install node npm install Etherium JS, run the following command to install test RPC globally. I think that is way beyond now. npm init, yeah. Then hero solidity contract function get my name, change my name. Yeah, maybe I should do this. Then add solidity. So after doing yarn add, then you do index.js. Then you run node index.js. Okay. Then install web3. Then deploying a contract. So node compile.js. Session error, invalid callback specified. Such.js len 31. So yeah, so I think this is the point where I may need to watch more of the course so that I don't I don't get stuck on search. So this is yeah, dependencies only Solidity has been installed. And maybe in the course this somewhere he talks about it. Is this Google Chrome? So here maybe just running with redeploying contracts with mnemonic names. Then skip Node.js, contract deployment, select requirements, project file walkthrough, syntax letters with the session error. Yeah, I think this is what we are getting. So we are getting Solidity session error.
Session error.
Invalid callback specified.
NPM.
So this is what I did node code compile.js, and then they told me a session error invalid callback specified. So maybe we just read this. Recently, Solidity released 0.5.0 and introduced many breaking changes. At the moment, this course only supports Solidity 0.2.45 or lower. If we recommend npm and install sock, and then
you've got to specify the version.
So maybe then now you can add so maybe in the package JSON, okay, it's updated. And then I can do node compile.js again. Invalid member of the std lib. Does it talk about that? It says remember to do this for each sock installation step in this course. So after that, he talks about compiling Solidity. Let me just listen to this.
We've now got the contents of our contract all put together. Now thinking about our project itself, we're going to start working very quickly on the compile.js file. The reason we're going to go directly to the compile.js file is that both the deployment process and the testing process is going to expect that we have a compiled contract ready to go. So in order to do any testing or any deployment, we first have to solve this compilation step. To do the actual compilation step inside our project, we're going to make use, to the Solidity compiler. Remember, we're going to pass some contract source code into that compiler, and that is going to spit out the API, which is our JavaScript interpretation layer of what the contract is, and also the contract bytecode, which is what we actually deploy off through the Etherium network. To install the Solidity compiler, we're going to install a tiny little node module. Back at my terminal, I'm going to make sure that I'm inside my project directory, and then I'm going to install the Solidity compiler as an npm package by running npm install --save solc. Solc is the actual Solidity compiler, and as you might guess, it stands for Solidity, it's the SOL part, compiler, that's the C. It's a pretty small module, so we'll just start the installation and then flip back over to our code editor. Inside of my root project directory, I'm going to create the compile.js file. So I'm going to make a new file, compile.js. Now, actually making use of the Solidity compiler is a require statement. You might be thinking we could write something like require contracts inbox.sol. And that's not the case. This is bad right here. Remember, whenever we require a file into a node project, the node engine will attempt to execute the contents of the file as though it were JavaScript code. So if we attempt to require in the contract file, it's going to immediately throw an error saying, hey, this isn't JavaScript code that you're requiring. So rather than attempting to directly require in this file, we have to read the contents of the file off of our hard drive. To read the contents out, we're going to be making use of two separate built-in standard library modules. Let's require both these modules at the top, and I'll tell you about exactly how we're going to use them. We're going to first require in path, and then we'll also require in fs. Again, these are standard modules, so we don't have to npm install them at the terminal. The path module is going to help us build a path, like a directory path, from the current compile.js file over to the inbox.sol file. The reason we're going to use the path module for this, rather than attempting to just write out the path directly, is that by using the path module, we are guaranteed to get cross-platform compatibility. In other words, if we try to run this compile script on either a Windows system or a Unix-based system, the path module will make sure that we always generate a valid path. So let's first start off by generating a path to the inbox.sol file. I'm going to say const inbox path, and we'll call path.resolve. And then we're going to pass in each or three portions of the path. The first portion is going to be underscore, underscore. So this is two separate underscores right here, dir name. Dir name is a constant that is defined by node, and it always gets set to the current working directory. So that will take you from your root directory or your home directory on your computer all the way to the inbox folder. Then the two separate second arguments we're going to pass in here are going to be the contracts folder and the inbox.sol file. So we'll say contracts and inbox.sol. Okay, so again, this is going to generate a path that points directly to the inbox.sol file, and we're jumping through this loop right here of using this function to make sure that it works on either Windows or Unix-based systems. Now that we've got our path, we can attempt to read in the contents of the file. We can read in the raw source code from our contract. To do so, we'll create another temporary variable, and I'll call this one simply source. To read in the contents of the file, we're going to use the file system module. I'm going to say fs.readFileSync. I'll then pass in the inbox path, and then we have to specify what type of encoding is used for this file, or for the inbox.sol file. And both UNI, it's going to be UTF-8 encoding. Okay, so now that we've got all of our source code from that contract file inside this source variable right here, we can now write the actual compile statement by using the Solidity compiler. We'll first start by requiring in the Solidity compiler at the top. So we'll say const solc is required, solc, and then we can call solc.compile. We'll pass in our source code, and we also have to specify the number of different contracts we are attempting to compile. In this case, it's just one. And that's pretty much it. Now, for right now, we're going to just console log the output of the compile statement, and that'll give us a better idea of what the compiler is doing. So let's just wrap that compile call and console log.
I've got to go. I'll try to get a token to access to the course and to be to participate in the mob next week.
Yes, I will get the link from Federico and send you so that you can buy
it. Okay. Thank you very much.
Okay. Bye.
In the last video, we finished up our compile.js file. Let's now run this at the terminal and see what happens. We should see a console log appear on the screen, but I'm kind of curious what data the compiler is really returning for us. So back in my terminal, I'm going to make sure I'm inside of my inbox project directory, and I'll run the command node compile.js, like so. The compiler usually takes a couple of seconds to warm up and actually compile our files, but after about 5 or 6 seconds or so, you should see a console log appear on the screen, like the one that I see. If we scroll up, you're going to see there's a lot of data that just got console logged. Let's go up, all the way to the top of the console log. Here we go. The return value from the compiler, whenever we call .compile, whenever we call the compile method right here, is always going to be an object. So here's that top level object. Inside that object, there's a contracts property that contains another object. This contracts object right here contains all the different contracts that were just compiled by our compiler. The Solidity compiler is built assuming that you might want to compile multiple contracts in one go. In our case, we have just one contract, just the inbox contract. But if we had other contracts we passed in at the same time, we would also see key value pairs inside this object that match up with the other contracts we attempted to compile. There's two objects, or two properties on this object that represents the compiled inbox contract that we really care about. The first is right in front of us, type code. Bytecode right here is the actual bytecode that we are going to deploy. Object, there is a contracts property that contains another object, like so. The compiler usually takes a couple of seconds to warm up and actually compile our files, but after about 5 or 6 seconds or so, you should see a console log appear on screen, like the one that I see. If you scroll up, you're going to see there's a lot of data that just got console logged. Let's go up, all the way to the top of the console log. All right, here we go. The return value from the compiler, whenever we call .compile, whenever we call compile method right here, is always going to be an object. Here's that top level object. Inside that object, there's a contracts property that contains another object. This contracts object right here contains all the different contracts that were just compiled by our compiler. The Solidity compiler is built assuming that you might want to compile multiple contracts in one go. In our case, we have just one contract, just the inbox contract. But if we had other contracts we passed in at the same time, we would also see key value pairs inside this object that match up with the other contracts we attempted to compile. There's two objects, or two properties on this object that represents the compiled inbox contract that we really care about. The first is right in front of us, bytecode. Bytecode right here is the actual bytecode that we are going to deploy to an Ethereum network. So yep, believe it or not, this series of numbers and letters represents the actual code of our contract that is going to be stored and executed on the blockchain. If we scroll down a little bit beneath that, you'll find another property called interface. Interface right here is our contract ABI. And remember, the ABI is essentially the communication layer between the Solidity world and the JavaScript world. Now, if you look at the actual ABI or the actual interface itself, you might be a little bit disappointed. You'll notice that there's really not a lot of information in here. The ABI really just lists out all the different functions that exist on the contract, all the different functions that can be called. It also specifies how many arguments, what type of arguments, what return values, and what type of return values are handled with each of those functions. I know the text in here is kind of hard to read, but you can see, for example, maybe we can start right up here at the top. You might see something that says name, there it is, set message. So this is an entry for our set message function. The set message function requires one input. So here's inputs that's called new message, and its type is supposed to be a string. So I know this is kind of hard to read, but you can kind of get a sense that the interface is specifying the different methods and their kind of format of inputs and outputs. If you want to, you can certainly look through some of the other properties on this object that got returned to us from the compiler. But again, the only two that we're going to be making use of are the bytecode property and that interface property. All right, now that we've got a better idea of what's going on inside the compiler output, we're going to go back over to our compile.js file, and we're going to remove our console log. Just to make sure I clean up the console log in a set of parentheses on the left and the right, like so. Now, of course, whenever we compile this file, we need to somehow make it available. The set message function requires one input. So here's inputs that right up here at the top, what return values and what type of return values are. Except there's really not a lot of information in here. The interface right here is our contract ABI. And remember so yep, believe it or not, this series of numbers and letters represents the actual code of our contract that is going to be stored and executed on a blockchain. If we scroll down a little bit beneath that, you'll find another property called interface. Interface right here is our contract ABI. And remember, the ABI is essentially the communication layer between the Solidity world and the JavaScript world. Now, if you look at the actual ABI or the actual interface itself, you might be a little bit disappointed. You'll notice that there's really not a lot of information in here. The ABI really just lists out all the different functions that exist on the contract, all the different functions that can be called. It also specifies how many arguments, what type of arguments, what return values, and what type of return values are handled with each of those functions. I know the text in here is kind of hard to read, but you can see, for example, maybe we can start right up here at the top. You might see something that says name, there it is, set message. So this is an entry for our set message function. The set message function requires one input. So here's inputs that's called new message, and its type is supposed to be a string. So I know this is kind of hard to read, but you can kind of get a sense that the interface is specifying the different methods and their kind of format of inputs and outputs. If you want to, you can certainly look through some of the other properties on this object that got returned to us from the compiler. But again, the only two that we're going to be making use of are the bytecode property and that interface property. All right, now that we've got a better idea of what's going on inside the compiler output, we're going to go back over to our compile.js file, and we're going to remove our console log. Just to make sure I clean up the console log in a set of parentheses on the left and the right, like so. Now, of course, whenever we compile this file, we need to somehow make it available to other files inside of our project. So at this compile line right here, we're going to add a module.export statement in front of it. And that's going to make sure that we can simply require in the compile file and immediately get access to our compiled source code. So right before solc.compile, I'm going to add on module.exports equals solc.compile, like so. So when we do this, we're now going to be exporting that big giant object that has the contracts property and then a list of all the contracts that were compiled. Now, because our project only has one contract that we're going to deal with, I think that maybe rather than returning the entire big nested object that comes back from the Solidity compiler, maybe we should really just be returning some details about the inbox contract. So I think that after calling solc.compile right here, we're then going to access the contracts property. And remember, on that contracts property, let's go look at it. So here's contracts. On the contracts property, we really only care about the key value pair of inbox right here. We really just care about this object, because this is what contains the actual bytecode and interface. So we just made reference to contracts, and then on contracts, we'll further pull off the inbox property. And notice this is :inbox, not just inbox. So to get access to that, we can put our square braces, and then in a string, capital I inbox. Cool. So now whenever we require in the compile.js file, we will get direct access to an object that contains just the bytecode property, which is our contract source, and the interface, which is our ABI. That's going to make it a lot easier when we go to deploy or test this contract in the future. We won't have to remember to destructure off contracts and inbox also. All right, this is looking pretty good. Let's pause right here, and then in the next video, we're going to start wiring up our testing solution with Mocha to make sure that our